Hello everyone. I'm showing you the new functionality which is called Vector Lattice and some historical background. Why came this idea up on our side? So at the beginning, when metal powder bed fusion was developed in the beginning of the 2000 years, the design software were not capable to design lattices in a way so that their functionality can be used, let's call it in this way. So the idea came up to generate those structures in the slice on the slice space, and we simply took up this idea from the history or from the past, and you can now assign to a certain volume a fill pattern which is called lattice. Let's call it this way. So, and how is this looking like? We use short vectors to generate this beam lattice structure. The benefit is due to small vectors in comparison to a point exposure, which is also sometimes capable for machine vendors like DMG or someone. The benefit of vectors is that they have a connection to the vector or to the previous layer. So the connectivity of the beam structure is better when you use a vector instead of a point exposure. What is also very beneficial to use this vector or lattice type is that it's very fast build it up on the machine. The disadvantage is we cannot visualize it and on your screen in the full visualization mode, let's call it in this way, but you will see it later on as well. Yeah, as I said, it's a special fill pattern which can be assigned to a part. Here is an example of those. I will show that later on. And from the parametrical side, it's very easy. You have three parameters: a cell size, the vector length, and a certain base rotation of the lattice. And how this is really looking like is what can be seen in this video. There are vectors which are attaching each other and going together and against them. And at the end of the day, when this scanning is successful or is done, you will end up in structures, for example, like this. So we assign to a volume a certain new pattern, and I will show you that in AM Studio directly. I will use a DMG machine, for example, and I will begin with a very easy example. I will take a cubic structure, make a sort of a base plate, let's call it in this way, and load an additional cube with 6 millimeters. They are now aligned in 0, 0, and the bottom part also on 0, 0. And adding a certain support on the bottom here. So I work now with two parts. The part which should be a solid, a standard scanned, or a full dense part, and a part which should be a lattice structure at the end of the day. I will copy those parts simply to add different lattice sizes in this field. So again, I align them about 35, and once again 17, and copy this one. Again, 70. So now the interesting thing is in the build strategy mode. Normally all those parts have the standard slice hedge profile. In my case, it's a tool, steel, DMG, whatever. And now I have stored a special parameter set, which is called lattice. What's the purpose of this lattice? I deactivated all the different areas, so no upskin, no downskin, only the volume is important. And for the volume, I have chosen the new lattice functionality. So beside parallel stripes, chess, you can now choose lattice. And by simply selecting this one, I would ask you to deactivate borders, because in this case it doesn't make sense to do a border around the lattice structure at the end of the day, and also set all the distances to 0 so that the lattice is generated to the end of the volumetrical part. And then you have those 3 main parameters. So the cell size, so how big should this beam lattice be? The vector length, which more or less indicates a little bit the beam diameter. So you cannot directly access the diameter of the beam, but you can change the diameter by the vector length and by the speed and power of those vectors at the end of the day. And then you can add a certain rotation. I will leave that for the beginning at 0. Assigning those lattice structures with different lattice sizes, generate, and then we simply generate one of those. And we will see exactly what we have seen in the video. So here is a 1x1 cell, 3x3, 5x5 cell. And when you go through those vectors, you can see that they are, let's go a little bit into details, they are connecting, and then they are getting away from each other. And at the end of the day, this ends up in a lattice structure, in a beam lattice, which is very easy to generate on the slicer base. But as I mentioned before, the only way to visualize how they are looking like is to use the functionality slice numbers. So I simply do not visualize one layer. I wanted to visualize 100 layers. And here you can see a bit how the structure will look like at the end of the day. So we cannot fully visualize the structure, but this can help to get a certain feeling of how the structure will look like. Let's go a little bit more downwards. It's too far, I think. So far to the first main idea. One thing I missed beforehand is, so which parameter these small vectors should be assigned. And a very good starting point is take the power and the speed from the border parameters of your standard profile. So because a border normally ends up in a solid structure, and this is a very good starting point. You can then make varieties, probably increase or decrease the power and the speed or something like that to vary the thickness of those lattice structures. I will load another part. It's a shell structure, because what's what's important is that this lattice should be surrounded by a certain volume, because otherwise at the end of the volume, I will jump back here, you will end up in a very weak structure at the end of the, or when there is no surface which is bounding the lattice, it can end up in a very weak bordering area of the lattice. Let's call it this way. So what I have generated here, it's a simple a shell, let's call it in this way, and I will load here again the cube. I will align them at whatever 50 and minus 50 in a height of 4, and this one at 50 and again minus 50 and a height of 6. No, the height should be 4, 5. So you have to generate two separated parts. The part that should be a solid and the part which should get the lattice structure. We cannot generate those structures in AM Studio, but I think for a standard CAD designing tool, it's not that challenging to generate two sub areas of a part, a lattice one, and for example a shell structure and the inner structure. And then you again can assign for the inner structure the lattice. Here it is. Let's take 2, for example, as cell size, assign, generate. I will leave the other parts here. Oh, sorry. You have to regenerate it. Let me restart AM Studio again. I think there was something with the numbers of cells, with the numbers of layers, so that it ends up that it cannot be visualized anymore. Sorry about that. Once again. So now it works. And again, we end up the solid part and the lattice, and the distance which you can find here is more or less the beam compensation of the original part. So the original part will get a beam compensation, but the lattice structure will end up at 0 of the boundary, and so you will end up in a connected lattice and solid part area, let's call it in this way. Exactly. Last but not least, I want to show you a more difficult part or a more interesting part. It's the bottle opener that you have seen beforehand. But one thing I wanted to mention, when you work with those lattices, you have now two separated parts, the parts which should be a solid and the part which should be the lattice. And normally they are aligned to each other so that you should not, you do not have to deal with the positioning of those. And after the export, they are aligned, and so that when you wanted to import them in the aligned way, use the S impart option here in the positioning and deactivate the distance to build plate. Load part, then I want to load those two parts. I stored them as inner and outer structure. And due to the fact that I have now imported them as in part, they are perfectly aligned to each other. So I do not have to align them manually, and this can help immensely to get aware of this alignment stuff. And again, I want to build a support underneath a bit, something like here. Going back to the slicer and hatching area, build the lattice. Use the inner part. So the inner part now gets again the lattice, and now we're generating this again. And you can see the part and the lattice. Once again, we can visualize multiple layers. And what also helps is to, give me a second. Oh, the slicer settings were beside, I haven't seen them, is to deactivate the arrows. Because then you get visualized more vectors. So again, you have the outer structure, which should be a solid, and the inner structure, which ends up in a lattice behave exactly the way that it is done here. Here's an additional part, which is the letters, or the CADS additive letters were added as a third part, which I sliced, and so I could generate this part. Yeah, so far to the main introduction about the lattice.